Yeah, hi, welcome. Welcome to my first peek into game development. I was building a 2D game from scratch and I was trying to use the new WebGPU API. So, let's have a few words about me. So, I'm Lea Rosema, she, her. I'm a front-end developer working at Novatec GmbH. And I'm in love with the web platform. My focus at my daily work is normally web standards and accessibility. And in my spare time, I do digital arts and shaders with WebGL. And yeah, that's kind of my hobby. So I have a CodePen profile where I occasionally share some shader arts. I can just switch to this tab if that works or not. Yeah, this is my profile. I wanted to show it shortly. So this is stuff that I make in my free time. Something like that, where you can play with the sliders a lot. So, but let's go back to my talk. Yeah. So the agenda is I'm telling about a bit about the game, the stack which I used, then the use statistics of WebGPU, how's the implementation status across browsers, and yeah, I tell a lot about my approach, which I took, and yeah. So in the agenda, you can already see that I used multiple implementations for my game because the usage statistics of WebGPU is not so great yet. So let's talk a bit about the game. Which game did I do? I made some sprites, some pixel art sprites for a Boulder Dash game. So just a few simple sprites, a wall, a block of sand, a stone, a gem, a door, a ghost, and an ugly miner. Yeah, the original game is created by Peter Lipa somewhere on the Atari computer in the 1980s. And this is what I tried to build. The stack that I used is a very basic stack. So I used a static site generator in case I wanted to build a little website around the game. So this is where 11t comes in handy. I used a bundler, which is ES build. ES build comes with TypeScript support built in. And I used Lightning CSS for my CSS bundling processing step and vanilla web components. For testing, I did use some Jest testing, but I didn't do too much testing because it was a free time project. Yeah, so can I use WebGPU? Yes, I can play with it. So in Chrome, it is already stable, and in Firefox, it's behind the flag. But in Safari, it's still not supported. And if you want to ship it, then you will have to provide some kind of fallback, something like WebGL or even Canvas 2D. Yeah, and the approach I took is I just set up an interface where I pulled out my whole rendering into an interface. Which methods do I need? I need some method for setup, like okay, set up the textures and stuff, and then I need a method for paint a frame on the screen, and a method which is called when the canvas is resized. So this is basically my interface I have to implement. And for first MVP, I just used Canvas, and this interface technique is a common software architecture pattern. Um, so you depend on interfaces rather than classes. You may know this if you're a Java developer from the Spring framework, or if you're an Angular developer, you know this also from Angular, where the dependencies are injected into the classes. Yeah, and this way you can provide different implementations and you can make your code very flexible via this technique. So first of all, I did use a Canvas 2D for a quick MVP. And the benefit for Canvas 2D is, of course, okay, you can use it very easily. You can just call context.drawImage and you can draw your sprites on the screen at your wanted XY coordinate, and you get results pretty quickly. And the drawback is it can be pretty slow. So, yeah. So I went. So the next step I went was I added a WebGL implementation. The WebGL implementation is works different than the Canvas implementation. You have to provide a geometry, and the WebGL API can provides you an API for basically drawing points, lines, and triangles. So it's basically about drawing primitives, and yeah, you can. First step is to specify a bunch of vertices. And with these vertices, you can make up a shape. And in my case, I just specified two triangles filling out the whole screen. Like I put four vertices, and then I have two triangles, and I fill the whole screen with it. And this way, I can put the code for the graphics into a shader. So shader is a function. So the vertex shader takes the coordinate data from the points and calculates it, and you can do some further processing with it. If you are in a 3D space, you can do some camera perspective projection. If you are on a 2D game, I just use an identity function where I just pass through the whole data. And the whole magic in my game is in the fragment shader, where I have a function. There I get the XY coordinate of a pixel, and as a return value, I get a color. So, and this is basically a void main, so like a program. And this program is executed in parallel on the GPU for each pixel on the screen, which is pretty awesome, I think. So when I wanted to move to WebGPU, the way isn't that far because the same concepts apply also in WebGL as also as in WebGPU. So both APIs have attributes, like you pull data from a buffer into the vertex shader. Then both APIs have uniforms, like shared variables you pass to your shader programs. Both APIs also have varying variables where you pass data from your vertex shader to your fragment shader. So vertex shader is about the pixel coordinate, the shape, and the fragment shader is for calculating the color. And both APIs have textures, so ways to provide 2D or 3D data. Yeah. Also, both APIs provide ways to render to textures. So maybe you would ask now, what's the deal now with WebGPU when the concepts are basically the same? Yeah, so one thing that is quite a new concept is that the WebGPU API is stateless, and also the whereas WebGL is stateful. Like when you work with WebGL, it's like you have a bunch of global variables you set, and the whole API of the WebGL is about setting this global state. And the WebGPU API is about setting, you have a pipeline object and you basically pass a lot of parameters and work with these parameters. And so it's a lot more stateless. So it doesn't depend anymore which functions of the API you call before. And yeah. Another difference is the shader language. So when you work with WebGL shaders, you are working with a C++-like language. And in WebGPU, it's more like a Rust language. We'll have a look at the code a little bit later. And yeah, also there are some new features for the WebGPU. For one thing, you have compute shaders. So like you have a method to run computations on your shader. And also you have a storage buffer. And the big new difference for the storage buffer in comparison to the uniforms is that you have read-write memory. Like in WebGL, you have only uniform data where you basically only have read access to. In the WebGPU, you also have the storage buffers where you can also write to the memory. One drawback is that the WebGPU is more low level. So whenever you want to resize a texture, like load a 1x1 texture to your WebGL and then load 512x512 texture to your texture space, that just works with WebGL. In WebGPU, you have to destroy the texture and create a new one. And also there is something like if you want to address some variables like uniforms, attributes, you have to use indexes and you have to memorize these indexes, and you work mainly with indexes and not with names. This is one of the most differences. So let me show what I've built. And yeah, so this is something like the first running Boulder Dash demo. And first of all, yeah, you see the Boulder Dash game, and yeah, so it's already working a bit. So like you can also walk around, and you can also collect some gems. You can move here, and you can. Now I have lost the game because I have I've locked myself up. Yeah, but let's maybe just also now there's the little trick. What I haven't implemented yet is a nice menu to switch between the APIs. I have to do this via the dev console. So there is this dev console where I can basically switch the engine to WebGL. And yeah, in order to see a difference, I added some fog of war. So yeah, you can maybe barely see it, but it's now the outer corners are a bit darker now. And basically it's working like the same. Like, yeah. Yeah, and basically that's the WebGL API. And what I haven't finished yet was the WebGPU API. So there you just see some some nice gradient. But I have at least I have the code to a state that, where you can see some differences between each API, and you can switch forward and back to the API on the fly, which is also cool. Canvas 2D. Yeah, so this is basically my demo, what I built. And yeah, let's maybe look a little bit at the code. So yeah, I've built this little interface where I have this setup function, I have this frame and the set size function, and I have different implementations about it, like a canvas renderer, a WebGL renderer, and a WebGPU renderer. My game logic is here in the yeah, one part of the game logic is here the web component, which is a bunch of code. Yeah, maybe not too beautiful. Yeah, but it's basically a web component which takes the renderer instance as an interface, and there is this kind of level thing where I have the level logic. The level data is a little bit here in the, you can see it in the elements, where I defined it as a script type text plain. Maybe I can make this a little bit bigger. No, can I make this a bit? No. Yeah, maybe. So maybe you can see that I have here this level data as a little ASCII art in my code, and internally my web component parses this text and yeah, uses this as level data. So the level was quite straightforward to implement. Like, let me just go into the code, level TS. Yeah. There I have some, yeah, I built some tests here and just went iteratively through it. Like my level class should be able to pass a bunch of text. And yeah, I expect some things like how the field is going to look like with this. And yeah, this was quite straightforward to go through until I have my game logic. Yeah, and now I have these WebGL and WebGPU renderers and the canvas renderer. So the canvas renderer was pretty simple. Like, okay, I'm using a canvas getContext 2D, like setting up a 2D canvas context, and here you can see my renderer is getting the canvas instance and also a completely loaded sprites sheet and the level instance. So the basic things that I had to implement was this set size function, where I set the canvas width to the client width of the element of the canvas element multiplied by the pixel ratio, and the pixel ratio I have set at a cap to maximum 2 pixel ratio, because more than 2 pixel ratio is not too visible for this kind of pixel art game. Yeah, I also have some kind of resize logic. So like if you work on very small screen, the tile size shrinks. So I make sure that you can see at least 10x10 tiles on the screen. And yeah, so the level, the frame function was just a for loop essentially, and doing this draw image thing. Yeah. And when I go to the WebGL renderer, there I have a lot of WebGL API. And basically what I'm doing here is that I define my vertex positions, which is vertex positions for 2 triangles. And I pass this data to my shader program. So my shader program I have here in separate GLSL files, like a fragment shader and the vertex shader. The vertex shader just works as a pass-through function. So I'm getting the coordinate of each edge of the triangle for 2 triangles for the screen, and pass them as varying variables to my fragment shader. And the fragment shader is doing a lot of magic. So first of all, I'm using a lot of shared variables. Like I'm sharing the current screen resolution of the canvas. I'm sharing the size of my sprites sheet, and I'm also sharing the size of the level. And basically, here I have the function where I get as an input the current pixel position, and at the end of the function, after a lot of logic, I return a color. Yeah, I return a color in the end. And what I didn't manage to finish in time was I was trying to do this in WebGPU as well. But this didn't work quite well. But at least you can see the differences of the syntaxes. Here overall we have these inputs and outputs and structs, and I'm also using these indexes. Like here I have to specify indexes rather than names. Like here this location 0 and location 1 is quite important. And also, yeah, I'm doing this input and output. I'm sharing all my uniform variables I also put in a struct. And here I have defined a vertex shader in this program with an add vertex decorator, and where I get this input, and I return an output, and this output is passed to the fragment shader, and this is again an input, and then in the end there is a color which is returned, which is basically how the WebGPU shader language works. Yeah. So that's mainly it for my talk. Yeah. So in the end, I have also some basic learning resources here linked in my slides. Let's go back. Let's close this. Yeah. So here in my slides, I have some learning resources. There's a Code Labs by Google where you can walk through your first WebGPU app. There's also a WebGL fundamentals website where you can get the basics about WebGL. And also I have this WebGPU fundamentals, which is also a pretty helpful resource. And that's basically it for me, for my talk. So I have the code on GitHub, and my slides are also on GitHub.